Hello everyone, welcome to the channel. We have a quadratic expression x squared plus a times x plus 2a is equal to 0. And the question is, for what values of a this quadratic has two integer solutions? We want the roots to be integers. For what conditions of this a this quadratic will have two different or equal. This is not important, but we want this to have integer solutions. Now let's m and n be the solutions for this quadratic. Then the sum of these two roots will be equal to, this is the coefficient of x, negative a divided by this 1, our leading coefficient. So this is equal to negative a, and let me write this side, and the multiplication of these two, the product of these two, is equal to the constant term, which is 2a, again divided by the leading coefficient, 2a divided by 1, which is 2a. So let me write again. We have m plus n is equal to negative a, and m times n is equal to 2a. This is a system. Here a is a parameter. We want to find a values for which m and n be integers. This is our main goal. Now, to manipulate, actually to get rid of this a at the first place, we can multiply this first equation by 2 to get a negative 2a. Let me write 2m plus 2n is equal to negative 2a, and m times n is equal to 2a. So adding these two equations, we will have 2m plus 2n plus m times n is equal to 0. Now this is very good, since this is a Diophantine equation. We can find our integer solutions from this. Let me show you. We have, let's write m times n plus 2m plus 2n is equal to 0. Now this first two term may be written as m times n plus 2, and we have 2n here. To be able to factor out this n plus 2, we need 2 times n plus 2, since we have 2n already. Now this is equal to 2n plus 2 times 2, which is 4. So adding 4 to both sides, we are able to write this. We have factored this 2 and write this 2 times n plus 2. This is equal to 4. Now again, as I said, factoring this n plus 2, we will have n plus 2 times n plus 2 is equal to 4. And this is, as I said, very good, since we are interested in the integer solutions. Now, let me think about the possibilities. We have n plus 2 times m plus 2 is equal to 4. Integer solutions may be from 1 times 4, maybe 2 times 2, maybe 4 times 1, and the negative versions of this, negative 1, negative 4, negative 2, negative 2, and negative 4, negative 1. These are the old possibilities. Now let's write these solutions. Here n is equal to negative 1 and m is equal to 2. Here we have n is equal to 0 and m is equal to 0. This part n is equal to 2 and m is equal to negative 1. Here we will have n is equal to negative 3 and m is equal to negative 6. Here we will have negative 4 and negative 4. And lastly, we will have negative 6 for n and negative 3 for m. Now, actually, m and n are the substitutes I used. We are interested in the values for a. Let me remind you, a was actually a is equal to m plus n is equal to negative a. Let's write the solutions for a for each solution. Our a is equal to, here we have m plus n 1, so a is equal to negative 1. Here a is equal to 0 already. Here we have 1 again. Sum of these two is 1, so we have negative 1. Here we will have negative 9, so a is 9. This is negative 8, a is 8. And here we will have negative 9, so a is equal to 9. The set of solutions for a become negative 1, 0, 8, and 9. Let me check for you. Let me check for you for some values. This is the final result. Let's check. To check, we can use first negative 1. Let's say a is equal to negative 1. Then the original equation, let me show you, was x squared plus ax plus 2a. X squared plus ax plus 2a is equal to 0. If a is negative 1, we have x squared minus x minus 2 is equal to 0. As you all know, this is factorable. X minus 2 times x plus 1 is equal to 0. So the roots are integers, as you see. The second one was a is equal to 0. So x squared plus ax plus 2a becomes x squared plus 0 times x plus 2 times 0 is equal to 0. So we have x squared is equal to 0, and this also has integer solutions 0 and 0. The third one was 8. A may be 8, so x squared plus ax, x squared plus 8x plus 2a, which is actually 16. This is equal to 0. So from this, again, we can say x plus 4 times x plus 4 is equal to 0. So the solutions, again, are integers. And the last one we have found was 9 for a. A is equal to 9. Then x squared plus ax, which is 9x, and 2a is 18. This is equal to 0. Again, this is factorable. X plus 3 times x plus 6 is equal to 0. So we have integer solutions again. This is a very nice question, and I wish you like the video. Thank you for watching, and see you in the next videos.